Hey everyone, here we are for the central net force. We're going to do example 1 from your packet. In this, there's lots of things that the problem wants you to do, so I'm going to go through each step with you together. The first thing that they say in this problem is to construct a motion map for the car moving through the valley and back up the other side. One note that they do point on there is that the object is going at a steady speed. So to show and indicate steady speed, I'm just drawing arrows to indicate the direction of the velocity and show that it's going the same rate every single second. Now remember, velocity is two things. Velocity is how fast you're going, but it also has to deal with your direction. So if you have an object that is going a steady speed, you can do that, but right now this one looks like it is going in changing directions. It's going from pointing to the right, to pointing down, to pointing to the right again, to pointing back up. And thinking back to the bowling ball lab, in order to make something's direction change, that means your velocity is changing and there's an acceleration in towards the center of the circle. So the next step here is to draw a force diagram of the car when it's at the bottom part. I know that the force of gravity there is pulling straight down and that the road is supporting back upwards so you don't fall through the road. Now I've drawn the forces unbalanced. Why does it have to be unbalanced? Because unbalanced forces cause acceleration. Since the direction is changing, that must mean that we are accelerating around the circle. And remember, the unbalance has to be in towards the center. Next thing, we can find and calculate the net force that's making this car go around the bend by doing your mass times your velocity squared over radius. Mass is given at 1,200 kilograms. The speed is given at 25 meters per second. And the radius is also 25 meters. Plugging all our numbers into our equation, put in your mass, put in your velocity, 25 meters per second, and don't forget to square it. You'll forget to square it. Don't forget to square it. Divide by the radius, and that should calculate the amount of force needed to make you go in towards the center of the circle. And when you crunch all those numbers out, you get a net force of 30,000 newtons. The combination of those two forces has to add up to 30,000. And one thing that the problem does tell you in there is that the car weighs 12,000 newtons in the downward direction. However, the unbalance is upwards, so I need the upward force to cancel out that downward force in excess of 30,000 newtons. So if that's the case, that means that the support force from the road is 42,000 newtons, because if you combine those two, you'll end up with your total net force on the car. That's how you do number 1. Good luck.